Hi, my name is Itandegui Rivera, and this is my project for Practicum 2. It's a CNN MediaPy framework for real-time bidirectional sign language translation with the objective of enhancing social and educational inclusion of deaf community. Well, how we know, communication is essential for the inclusion in education and society. It's the principal way how humans work, communication. Without it, we wouldn't have anything. Less than 2% of hearing people know sign language, and 5% of population in each country has this disability. The idea is to develop a real-time bidirectional translation using a standard mobile device so that every people can have the access to it. The problem we notice is the lack of affordable, accessible bidirectional tools. I was trying to check and we don't have application to translate. There are some online, but there are only to text to signs. We don't have the opposite. And neither something that really works or we can use in fonts. So these people are still depending on human interpreters, the ones that are not available in every day. Like you can go to the supermarket and find an interpreter. So for these people, it's really difficult to integrate to society, go to schools, or get a normal job. The question to solve is, can a low-cost real-time bidirectional system be built? Can it be implemented in Mexican public schools? I'm Mexican, so my idea is that the final version of this can be implemented in my country because only 2 of every 10 people with this disease is able to attend to school. The objectives: develop and evaluate a functional prototype, no need for specialized hardware, combine sign to text and text to sign. For the future, how I say, integrate to Mexican Sign Language. Related work. I have been checking different papers about the same prototype. The best I found was signed for PSL, that I think is Pakistani. They tried to do the same to make a sign language translator. The problem with this is that was unidirectional, only sign to text. Other is that it's a language that is not so common. And at the end, it's just a prototype. It doesn't go to fonts and it's not commercialized. We have virtual sign, that is I think is the nearest to our project because they use a smartwatch. With the gyroscope, they can track the movement and the angle of the hand, and the smartwatch translate this and send it to your phone so that you can see the text of the signs there. Again, is unidirectional. Then we have Hospisign. This one was implemented in hospitals. It's really good because it's something really important, the hospital. So people was able to communicate what they were feeling, what the problem was, but it's really limited because it has only limited answers so that people can just communicate what they need, no more. And then we have Sign Speaker, that this was implemented in application like Teams, so that you can translate when you are in a call, but it's not something useful again in the day-to-day because you need to be in a meeting. So the problems we found in all the people that have tried is that you need especially hardware. For example, the Hospisign need a Kinect, others need gloves, and this is expensive and not accessible for everyone. Methodology. We use the ASL alphabet dataset that is in Kaggle. It has the letters of the alphabet. We have to resize the image and convert them so that will be useful for the mobile net. model that we were doing. We use MobileNet because it's light, it's easy, and it has pre-trained model, so it makes faster to train our model. The system architecture. Our program is divided in 3 sections. The first is the training of the model. The second is the sign recognition. For this, we use MediaPipe and the model already done. We open a video. We are going to show you after. We open the camera. With MediaPipe, we can track the hands. Then we use the CNN and to be checking with the model we already have, compare with all the training we did, and finally give you the right letter that you are doing with your hand. And for the third part, we use Twinkr to create an interface. So you get a window where you can introduce text. And when you press a button, you can see the signs that represent this text. We use a normal camera with OpenCV, hand detection with MediaPipe, the prediction with the MobileNet model, temporal smoothing filter for stability, sequential image displays for typed words. We also did augmentation so that we could have a better model. Offline results, we have a 90% precision recall and F1 score, so it's really good. And it doesn't show you a sign if it is not like more than 80% sure that is that letter. Common errors, it has some letters that are really similar, like A and M, so it has some confusions with it. And other problems we had was, for example, the background, if it has too many lights or something similar, it can have some delays. Limitations. Right now is working only with the static gestures, the same for text to sign. It only gives you the spelling. It doesn't have context or grammar. And we don't have the Mexican dataset yet. And right now it's being used in a laptop. I tried to make an application with Bulldozer, but still being so many work to do, I couldn't finish with it. But the idea was to implement it for Android. The conclusion, we could make a functional low-cost system. You don't need more hardware. So much work in the future, like create a new dataset, make the levels for video so that it can track like complete sentence. And that will be the end of this. Future work, how I said, recognize dynamic gestures, create Mexican dataset, add animated avatars for the text to sign, do it in Android, and finally apply in schools, hospitals, and public service. Thank you so much. Now we are gonna proceed to the code. Let me show you. Here we can see the code. We get the dataset from Kaggle. These are the libraries needed, like sklearn, TensorFlow, CV2, NumPy. The first we did was load the dataset, get the image size that we need, that is 24 for 224. We create different functions, for example, the dataset statistics, so we can see how many classes we have and how many image per class. We pre-process the image so that we could use it in our MobileNet, in our MobileNet. So we create a level encoder and we separate the image and assign a level. we build the model. This use MobileNet, so it gets some pre-trained models. Here we train and evaluate. We separate 20% for test and the rest for training. In the main function, we see the evaluation. We show sample image. We also see how many image per class we have. And we create the document for the levels and the best model to use in the future. Here we can see our distribution classes. We have 300 images per class. We use only 300 to make it faster, but in reality are 3000. Here we can see one image sample. And finally, the evaluation. We can see a really good F1 score. That means a really good accuracy. And this will be the second part where we use MediaPipe, and it's gonna translate. Also, we resize the image that are captured for the camera, and we mix with the model already created so we can see the translation. So I'm gonna turn off the camera so I can show you this. Here you can see, for example, N, and it doesn't show anything if you don't have more than 80%. This is B and W. So I said it has some problems with letters that are so similar. But it works really good. It takes some delays, but the accuracy is really nice. Finally, in the last part, we use Tinker so that we could have a nice interface for the users, and we can translate text to sign. Here you introduce your text, and when you press translate, you're gonna see the translation. This use only image from the dataset, and the idea is to create an avatar and also give context and get some data set with video so it can show you the full thing, like for example, hello, instead of be doing the spelling. Well, this will be all my code. Thank you so much.